How are you, my students in organic chemistry? Today we will be discussing about lesson 4. It's about cycloalkanes and naming alkenes. At the end of the session, you will be able to determine the structure of cycloalkanes and give the name of alkene. What is cycloalkanes? Alkanes whose carbon atoms are joined in rings. They have the general formula of CnH2n, where N is equal to 3, 4, and so on. The simplest cycloalkane is cycloprophane with the formula of C3H6. Notice that the cycloalkanes is composed of carbon atoms joined in a rings. So it forms a structure like a ring. That's why it is being called cyclo. So means cycle. It forms like a ring, no? A ring shape or a round shape. That's because of the connection between carbon atoms forming this structure. A cyclic structure of the carbon atoms bonded together. And you can see that the hydrogen atoms are all bonded together in the carbon atoms. So the cycloalkane, the simplest type of cycloalkane is the cycloprophane, as you can see, with the general formula of C3H6. Here are the structures of the first 4 cycloalkanes under simplified forms. So you can see the first one is the cycloprophane containing 4 carbon atoms. The cyclobutane with 4 carbon atoms. Cyclopentane, which consists of 5 carbon atoms, and the cyclohexane containing 6 carbon atoms. Many biologically significant substances such as cholesterol, testosterone, and progesterone contain one or more such ring systems. Theoretical analysis shows that cyclohexane can assume 2 different geometries that are relatively free of strain. By strain, we mean that bonds are compressed, stretched, or twisted out of normal geometric shapes. Cyclohexane can exist in various shapes. The most stable is the chair form, and a less stable one is the boat form. 2 types of hydrogen atoms are labeled axial and equatorial. You can see in the figure, the first molecule, you can see the axial, and you can also see the equatorial atoms. And of course, the difference between chair form and the boat form. Does it really look like a chair? Yeah, it's similar to a chair. And also the boat form. Now, let's talk about alkenes. What is the difference between the alkanes and the alkenes? So, the alkenes, also called olefins, contain at least 1 carbon-to-carbon double bond. So, take note of that. There is at least 1 carbon-to-carbon double bond. So, alkenes have the general formula of CnH2n, where N is equal to 2, 3, and so on. The simplest alkane is C2H4. That's ethene, in which both carbons are double bonded to each other. You can see in the structural formula of the ethene. So it is consist of two carbons bonded together, double bond. There is a double bond that exists between two carbon atoms, and we have a total of 4 atoms attached to the carbons. So this is the simplest alkene called ethene. Okay? So the name of the alkene, or the compounds containing at least one carbon-to-carbon double bond, ends with ene, or in. So we have, for the two carbon atoms, you have the ethene, we have the prophene, butene, pentene, hexene, heptene, octene, nonene, and decene. Below are the list of the alkenes, the number of carbon atoms, and its molecular formula. So you can see in the table the summary of the alkene. As you can see, the number of atoms, we started from the ethene containing 2 carbon atoms, and the molecular formula is C2H4. Carbon 3, or the alkene having 3 carbon, is the prophene, C3H6. Then 4 carbon atoms, butene, C4H8. 5 carbon atoms, pentene, C5H10. With 6 carbon atoms, we have the hexene, C6H12. 7, we have the heptene, or C7H14. 8, we have the octene, C8H16. 9, we have nonene, C9H18. And 10, decene, or C10H20. Naming alkenes. In naming alkenes, we indicate the positions of the carbon-to-carbon bonds. The names of compounds containing carbon double bond to carbon end with ene, or in. As with the alkanes, the name of the parent compound is determined by the number of carbon atoms in the longest chain. Example, we have CH2, CH, CH2, CH3. So you can see we have how many carbon atoms. So we see that the longest continuous chain of carbon atom is composed of 4. So that's why we have numbered 1, 2, 3, and 4, or carbon 1, carbon 2, carbon 3, and carbon 4. So in alkane, an alkane with 4 carbon atoms is called butane. But because our molecule here has a double bond, it is now an alkene. Okay? So take note of the difference. The alkane, which is consist of single bond between each carbon, ends with, the name ends with ane. That's ane. But here, once a molecule is composed of at least double bond or there is a double bond that exists between carbon to carbon, this becomes an alkene. Take note, alkene. Alkene has a name ending with E-N-E that is being pronounced as in. Okay? So, going back to this example, you can see that we have how many carbon? We have how many carbon atoms in the longest continuous chain of carbon atoms is composed of 4. So, because it has a double bond that exists between carbon 1 and carbon 2, so the name of this is butene. Okay? So take note, this is different from the alkane. This is now butene with E-N-E ending. The name ends with E-N-E. Okay? The double bond, take note of the double bond also. The double bond is located between what carbon? So, the double bond is located between carbon 1 and 2. See? The numbers in the names of the alkenes refer to the lowest number carbon atom in the chain that is part of carbon double bond to another carbon. Therefore, the name of this alkene is 1-butene. Okay? So again, this is an alkene. This example is an alkene because it has a double bond between carbon atoms. In our definition earlier, the definition of the alkene, it is defined as a molecule having at least one double bond between carbon atoms. So in naming this, we will give the name, or we will mention the number, okay? The number of the lowest number of atoms, or the location of the double bond. The lowest number of atoms, of the carbon atoms, where the double bond is located, will be the reference of the name of the alkene. So the lowest one. So take note that the double bond in this example is located between carbon 1 and carbon 2. But the rules states that the number that we are going to use in naming this alkene is the lowest number of carbon. So between 1 and 2, which is the lowest number? Obviously, it's 1. Therefore, the name of this alkene is 1-butene. Okay? 1 indicating the lowest number of carbon where the double bond is located, and butene because this alkene is composed of 4 carbon atoms. That is but for the 4 carbon atoms. Another example. Here you can see that the longest continuous chain of carbon is still 4, right? So we have carbon 1, carbon 2, carbon 3, carbon 4. So that is, or it has 4 carbon atoms. But also notice that there is one double bond that exists between carbon 2 and carbon 3. Okay? The location of the double bond is now at carbon 2 and carbon 3. So, again, we will use the lowest number of the carbon where we find the double bond. So, between the carbon 2 and carbon 3, of course, we will use the lowest number, which is the 2. Therefore, the name of this alkene, this example, is 2-butene. Okay, another example. In this example, you can see how many carbon, how many longest continuous chain of carbon do we have? Okay, we have 6. We have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So that is what? This is what type of organic compound is this? Okay? So this is what? Having 6 carbon atom. Obviously, this is hexene. Okay? Hexene. Because it has 6 carbon. We have 5 pentane or pentene. 6 we have hexene. Okay? It's hexene because it is an alkene. Okay? Look at the example. It becomes an alkene because of the double bond that exists between carbon 3 and carbon 4. So there are 6 continuous carbon chain. This is an alkene because there is a double bond between carbon 3 and carbon 4. Now, giving the name, we will use the lowest number where we can find the double bond. So between 3 and 4, of course, we will use the number 3. Therefore, the name of this alkene is 3-hexene. Okay, another example. How many carbons? You can see a continuous chain of carbon. You can see because it was not numbered. So we have 1, 2, 3, 4, 5. 5 carbons. And can you see the double bond? Yes. The double bond is found in or between the carbon 2 and carbon 3. So because there is a double bond, this is an alkene. Okay? This is an alkene because of the presence of the double bond. So giving the name, it will give us the name 2-pentene. 2 because the double bond is located between carbon 2 and 3, and we use 2 because the 2 is the lowest number, and pentene because it has 5 carbon, that's penta, meaning 5. Pentene, E-N-E, the ending of the name is E-N-E because this is an alkene, meaning it has a double bond between carbon atoms. So how are we going to give names to our alkenes with the attached alkyl group and substituent group? So first, let us have some review of what alkyl group is. During our previous lesson, we already talked about the alkyl group. What is this alkyl group? So this is an alkane less 1 hydrogen atom. Okay? An alkane minus one hydrogen atom becomes an alkyl group. For example, when hydrogen atom is removed from the alkane or the simplest alkane methane, that is CH4, what is left? We are left with CH3. When we remove the one hydrogen, what is left is the CH3. So this becomes an alkyl group called methyl. Similarly, when we remove a hydrogen atom from the ethane, which is a formula of C2H6, it will give us an ethyl group or the C2H5. So just take note that the alkyl group is an alkane, an alkane minus one hydrogen that becomes an alkyl group, and the name ends with YL. Like methane becomes methyl, ethane becomes ethyl. So look at the figure below. So names of alkyl groups. Alkyl groups are named by replacing the suffix ane with YL. Therefore, when we remove one hydrogen from the methane, that is CH4, it becomes CH3, and that is, the name becomes methyl. When we remove one hydrogen from the ethane, ethane is C2H6, that becomes C2H5, and the name becomes ethyl. So those are the common alkyl groups you can see here, and the formula. The simplest one is the methyl. CH4 less than one hydrogen becomes CH3. That's methyl. And ethyl, we have also the propyl and propyl, butyl, isopropyl, and T-butyl. How about substituent group? So substituent group is an atom or group of atoms which replaces one or more hydrogen atoms on the parent chain of the hydrocarbons. Again, when you say substituent groups, it substitutes or it replaces the hydrogen atom in the molecule. Okay? These are some of the common substituent groups. You can see here the functional group or the substituent group, the formula, and the name. So we have NH2, that is amino, F, that is fluoro, Cl, that is chloro, Br, that's bromo, I, iodo, and O2, that's nitro, and CH double bond to CH2, that is vinyl. So those are the substituent group. Why are we discussing this one? Because in naming alkene, we might also encounter those alkenes with alkyl group or substituent group attached to it. That's why we need to go back to this lesson. So in naming alkane, we must also specify whether a given molecule is a cis or trans if it is a geometric isomer. So here we have a new vocabulary. We have the cis and the trans. Cis and trans. So what is meant by geometric isomer? So geometric isomers have the same structural formula but differ in arrangement of groups at a single atom, at double bonds, or in rings. In the cis isomer, the two atoms are on the same side of the carbon-to-carbon bond. In the trans isomer, the two hydrogen atoms are across from each other. So please take note of this. When we say cis isomer, the hydrogen atoms are on the same side. They are on the same side of the double bond, carbon to carbon double bond. They are on the same side means they are at the top or they can be at the bottom. They are called cis isomer. When we say trans isomer, trans means they are at the opposite side. They are at the opposite side. Or they are across from each other. Meaning, the hydrogen, one hydrogen can be at the top and the other one can be at the bottom of the carbon-to-carbon double bond. So here you can see an example that the hydrogen that is bonded to the carbons having the double bonds are on the same side. You can see that the two hydrogen atoms being encircled. These two hydrogen atoms, since they are on the same side, they are at the bottom. This example becomes the cis isomer. So you will just look at the position of the hydrogen atoms that are bonded to the two carbon atoms containing the double bond. Once they are on the same side, either they are at the top or at the bottom. As long as they are on the same side, they are, or this molecule is a cis isomer. Cis, meaning on the same side. In this example, you can see an arrow pointing to hydrogen and another hydrogen. In this example, you can see that the two hydrogen atoms that are attached to carbons, to the carbons with double bond, are on the opposite side. One is at the top and the other one is placed at the bottom. So this is an example of trans isomer. So it's just easy to recall. So when we say cis isomer, the hydrogen atoms are on the same side. When we say trans isomer, the hydrogen atoms are on the opposite side. Now, in this example, particularly, you can see now that we have already replaced the hydrogen atoms with an alkyl group. Notice the presence of alkyl group attached to the carbon 4. Look at this. There is an alkyl group called methyl, that's the CH3 being encircled. The CH3, that is the alkyl group called methyl. Methyl, attached to the carbon 4. Okay? Now, notice also that the hydrogen atoms that are bonded to carbon containing double bond are on the same side. They are at the bottom of the carbon atoms. Therefore, the name of this alkene is, okay, so let's give the name of this. What is the name of this alkene? So first, we will mention the alkyl group attached to the parent chain of carbon. So the name is 4-methyl, okay, because there is an alkyl group methyl attached to the carbon 4, 1, 2, 3, 4, to the fourth carbon. There is an alkyl group methyl attached. Cis, because this molecule is a cis isomer, because the hydrogen bonded to the carbon containing the double bond are on the same side, because so that is cis. 2, because the lowest number of carbon where we can find the double bond is 2, because the double bond is found between the carbon 2 and 3. So we have 2. And the name of this alkene is hexene. Why? Because we have 1, 2, 3, 4, 5, 6. We have 6 carbon atoms. So that is hexene. So the name is 4-methyl, that is the alkyl group attached to the carbon 4. Cis, because the hydrogens that are attached to the carbon containing double bond are on the same side. 2, because the lowest number of carbon where we can find the double bond is the carbon 2, and the name of the parent chain, or the number of carbons, the longest carbon, continuous chain of carbon is 6. And because of the double bond, it is an alkene. The name, therefore, is 4-methyl cis-2-hexene. Another example, here you can see the alkyl group methyl, also attached to the carbon 4. But what's the difference between the previous example and with this new example is the location of the hydrogen atom. You can see that the hydrogen atoms that are attached to the carbons containing the double bond are on the opposite side. One hydrogen is at the top and the other one is at the bottom. So this is a trans isomer. Now let us give the name. So the name is 4-methyl, that is the methyl group attached to the carbon 4. No? 1, 2, 3, 4, we have the methyl attached to the carbon 4. Trans, because the hydrogens that are attached to the carbon containing the double bond are on the opposite side. 2, because the lowest number of carbon where we can find the double bond is the carbon 2, and hexene, that is the name of the parent chain or the longest continuous chain of carbon. We have a total of 6. So the name is 4-methyl trans 2-hexene. Another example, we can see an alkyl group attached to the carbon 1, 2, 3, 4, 5. You can see first that an alkyl group ethyl, that is C2H5, is attached to the carbon number 5. And another thing is the hydrogens or the hydrogen atoms attached to the carbon atoms containing the double bond are on the opposite side. So it means this is a trans isomer. Then we have also the carbon 3. 3, the lowest number of carbon where we can find the double bond is at the carbon 3. And heptene, because we have how many carbon atoms? 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms, and that because of the double bond, this is now a heptene. So the name is 5-ethyl trans 3-heptene. In this example, you can see the alkyl group ethyl attached to the carbon 5. That's why the name is 5-ethyl. Then we have the hydrogen atoms attached to the carbons containing the double bond. They are on the same side. So this is a cis isomer. So we have cis. 3, because the lowest number of carbon where we can find the double bond is the carbon 3. Because the double bond is located at carbon 3 and 4. So we use 3. Heptene, because we have how many carbon atoms? 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms, that is heptene because of the presence of the double bond. In this example, in this particular example, you can now see the two alkyl groups attached to the parent chain. We have two ethyl group attached. One is attached to the carbon number 2 and another ethyl group attached to the carbon number 5. Carbon 2 and carbon 5. So how many ethyl are attached to the parent chain of carbon? We have 2 ethyl. Okay? Therefore, the name of the alkene is 2,5-diethyl. Okay? Why 2,5? Because the first ethyl or the ethyl are attached to carbon 2 and carbon 5. Why di? Because we have 2 ethyl groups attached. So we have diethyl. Remember, when we have 2 ethyl, we have 2 alkyl groups, then we will use the prefix di. And then cis, because the hydrogens are attached to the carbon containing double bond are found on the same side. 3, because the lowest number of carbon where we can find the double bond is carbon 3. And the parent chain is or has 7 carbon atoms. So that becomes heptene because of the presence of the double bond. Therefore, the name of this alkene is 2,5-diethyl cis 3-heptene. Next example, you can see that the alkyl groups attached, we have 2-methyl attached to the carbon 2 and to the carbon 5. So the name is 2,5. Because we have 2-methyl, we will use the prefix di. Dimethyl. Cis, because the hydrogens attached to the carbon containing the double bond are on the same side. So that is cis. And 3, because 3 is the carbon, the lowest number of carbon where we can find the double bond. And the name, the parent chain is or has 7 carbons. So that becomes heptene because of the presence of the double bond. Next example, you can see how many alkyl groups attached. So we have 2 ethyl groups attached to the carbon 1 and carbon 5. So we will name it as 1,5-di because we have 2 ethyl groups. Diethyl trans. Why trans? Because the hydrogen, as you can see, that are bonded to the carbons containing the double bond are on the opposite side. That's why we use the term trans. Trans 3 is the number of carbon, the lowest number of carbon where we can find the double bond, and the parent chain has 7 carbons, so we have heptene. Therefore, the name of this alkene is 1,5-diethyl trans 3-heptene. Now, in the next example, we have the substituent group. The substituent group, bromo. So the hydrogen was replaced by the substituent group bromo. So we have how many bromo? We have 2. So we will use the prefix di. So the location, where can we find the substituent group? We can find them attached to the carbon 1 and 5. That's why we use 1,5-di, because we have 2 bromo. That's why we use di, bromo, and then trans. Why trans? Because we have hydrogens attached to the carbon having the double bond are on the opposite side. That's why we use trans. And 3 is the location of the lowest carbon where we can find the double bond. And we have 7 carbons, so we have heptene. That is an alkene. Heptene, because of the presence of the double bond in this molecule. So 1,5-dibromo trans 3-heptene. So that is how we give names to our alkene. I hope that you already distinguish or differentiate alkane from alkene. And I am going to give you another chapter test posted in your Google Classroom, or I'm going to post it also in our group chat of the BS Agri first year. So thank you guys for your time watching our video lesson, listening to it, and hopefully you can answer all the questions or the given exercises to you. And once again, Merry Christmas and God bless to everyone.